Here we go. Huh? Tell me wants to take the first one. We'll be back in a second. Hold on. Alright, kiddos. How many marks get set? And Addie, who's secant the reciprocal of? Who are we looking at? Yeah. So then we're looking at y equals 3 plus 2 cosine of 4x plus pi over 8. We're looking at cosine. We'll get to the clues and the tricks and all that in just a second, but let's look at the cosine. So, you did volunteer, Toby. So Toby, what's the first thing that you guys graphed?
Oh, well, we went up 3 first.
Okay. Because it's the sine to the axis, yeah?
Yeah.
So then, hold on, give me 1 second. I think I need a little more space in the upper portion. So, up 3?
Yeah.
Tara, what did your group do next after going up 3? Up to 5. Do you know why? We shifted up 3. That's why the middle of the graph came up 3. But then, what's that called? Remember? It's how high, how low. Amplitude. Yeah. Amplitude is how high, how low the wave goes, right? So how high, how low the wave goes, we need to go 2 up and 2 down. So I'm going to go ahead and do the upper bound and a lower bound. Now the nice thing is I'm on a smart board, so in a second I'm going to select all of this. Once we have the graph, I'm going to make it smaller. Maybe some of you guys know why. I have to plan ahead for the secant. Right now, if this was on your paper, is this going to be a good secant graph?
No.
Because what do you have to do to the cosine?
Bounce off.
You got to bounce off. Okay, coming back. Since I'm on a smart board, though, I'm zooming in on the cosine and then go ahead and make it small, and then I'm going to bounce off in just a moment. Okay. Rebecca, what did you guys do next? Nice. What was it? Good. So the sine to the axis was out. Let me recap real quick. Y equals 3. That's this line right here. The amplitude said to go up 2 and down 2. Hence why we went up to 5 and we went down to 1. And Rebecca was like, hey, let's look at the initial point. And her group figured out the initial point is, why did she say negative pi over 8, cool kids? The addition means going to the left pi over 8. Now, hold on, you went further, right, Rebecca? What did you guys say? 1?
Yeah.
Okay. Why did they say 1?
It had to be in the dark.
It does need to be inside the bound, so between 1 and 5, that's true. And what kind of curve is it? Cosine. So at the initial point, cosine starts at the highest. Pause. So highest, we're not going to start at 1. If this was a minus, your 1 would be right, because then it would be flipped down, so it'd be starting at the lowest. But since it's a positive cosine, remember cosine starts at the top?
Yeah.
So then look at your graph, and instead of 1, let's go ahead and change that to be a 5. Does that make sense? Cosine needs to start at the top. Now I'm not going to mark down my pi over 8 quite yet, because I don't know whether to make it small or whether to make it big. And does anybody, just a volunteer, know what I have to look at to figure out whether to make it a big tick mark or a small tick mark?
Period.
Period. That's the piece I'm missing. So Andrew, go ahead, because Abby already answered. How do we find period?
You can find the period by going 1 over b.
And who is b?
B is 4.
Okay. So what is my period for this one?
Pi over 2.
Pi over 2.
And then we find our quarter cycle.
Nice. He kept going. Did you guys keep going?
Yep.
Quarter cycles would have said take that pi over 2 and do what to it? Multiply it by 1/4, and what did you get?
Pi over 8.
Pi over 8. Oh, okay. So it looks like our tick marks are going to be pi over 8s, right? Or we need to go pi over 8s. And the nice thing is our initial point is a pi over 8 also, so we can, it's actually nicer than I meant it to be on accident. Anyway, pi over 8, I'm going to go ahead and just make my tick marks pi over 8s. I actually meant it to be a little bit harder, but oh well, that's okay. So I can do, let's see, negative pi over 8, that's going to be pi over 8. 2 pi over 8s, wouldn't that be pi over 4? 3 pi over 8s, 4 pi over 8s, I think that's pi over 2, yeah? So at negative pi over 8, we're going to start cosine at the highest. And then where's the next key point going to hit? At the middle, right? And then the next one's going to hit at the bottom, the next one's going to hit at the next one's going to hit at the, and then if you guys count, ooh, making it dashed, right? And if you guys count just to double check, the distance is going to be 1, 2, 3, 4. The period from start to end was 4 pi over 8s. 4 pi over 8 is pi over 2. Ooh. Questions on the cosine graph? I'm doing what I said I was going to do. I'm going to select it all. I'm going to make it small.
Whoa.
Whoa! Go ahead and extend, but no questions on the cosine graph? How many groups had it mostly right? Maybe all but like one thing. How many groups had it all the way right? We all missed a little something, huh? Okay. So our questions got answered. Now it's time to graph the secant. Ooh, let's pick a new group. Done you. Ah! Back of the room. Hi guys. Who are we going to choose? What's the very first thing? This is the question. What is the very first thing we're going to graph to get to secant? Don't give me the whole thing. Just give me what's the very first thing we're going to graph. Sure, John. Go ahead. Yeah. How are we going to graph them? When did they occur? Or when? Good. Ah, okay, that's where it gets tricky. Intercepts, right? X-intercept. Wait. It's only x-intercepts when it hasn't been shifted. So he figured out we're doing the vertical asymptotes. We're looking at intercepts. Joseph, which intercepts are we looking at?
The ones with the sinusoidal axis.
Got it. So we're looking at, just like it would be before, the x-axis is the center, is the equilibrium, but that equilibrium got shifted to the sinusoidal axis. So we're going to go ahead and take these intercepts. We're going to make vertical asymptotes. There's going to be one over here. Eventually, there's going to be one over here eventually. Does that make sense? Intercepts with the vertical asymptote. Intercepts with the vertical asymptote are, intercepts with the sinusoidal axis are the vertical asymptote. If the whole thing gets shifted, it's no longer x-intercepts. Now it's with the sinusoidal axis. So then, which points do I get just to fill in and say, oh, they stay the same with secant? Which points stay the same? Melanie? Do you remember?
Sorry, could you say that?
It's okay. I'm trying to get to the secant. I have the cosine. We've done our vertical asymptotes. Do you remember which points get to stay the same? That's okay. Do you remember what I'm supposed to do in graphing secant now that I have the vertical asymptotes? The two words in the whole quotation marks. Ask your group. Help out. David or Ryan?
Maximum.
Okay, maximum and minimums. The peaks and the valleys. The peaks and the valleys are the ones that we get to shade in. But help her out with the second question. I asked her, how do we graph secant? How do we do it? Bounce off. So we come from the vertical asymptote to the point and we bounce off. Come up from the vertical asymptote to the point and bounce off. Come down from the vertical asymptote and bounce off. So bounce, 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 bounce. Does that make sense? So the vertical asymptotes first. Well, we need the cosine first. Then we need the vertical asymptotes. Then we join at the peaks and the valleys, the maximums and the minimums. Kiddos, throw this into your calculator. Ooh, how do we put secant into our calculator? We talked about that yesterday. Will this look like yours? P.S. If I were you, I would make your graphing window. You can actually do this. Negative pi over 4 is what my x min is. So pi over 2, that's my x max. My y min would be like negative 2 to negative 2 to 7, 10, something like that. But if you want, you can even try to make your window match mine. Somebody in your group has to have a calculator. Oh! I know, graphing calculator group. See See if it matches. P.S. Don't be in degrees. Degrees, the pi over 8s and the pi, they would not be happy times. If it was degrees, I'd have to go like 180s and 360s and 90s and 45s and 22.5s. Who's secant 1 over? You gotta be careful how you put this in. It isn't super fun to put a nasty transformed one in. I'm giving my calculator because some of you aren't gonna like putting it in. And if you can't get the picture, show your calculator to someone else in your group and be like, what am I doing wrong? This one's kind of hard to put in. You like your calculator, but can you use it?
See, I don't have to Look at that. Did anyone else get done?
Is anybody getting it to match?
Yes.
Are you doing the 1 over cosine?
Pretty cool. It's a handheld calculator.
I know it's weird, but did you think about doing the parenthesis and then the other parenthesis?
Oh, we gotta do 5 lessons. Hold up. I'll give it to you over. I'll probably give you $1.
Hey guys, what do you make our wine? Kiddos. Swear. Have you seen the movie Up?
Yeah. Overrated.
Half of you? Squirrel. Pay attention. What's our X-Men? The sad thing is a lot of you that are distracted are the ones who were unprepared for class today and didn't have your graphing calculators. You should be flying below the radar, making sure that I don't randomly decide to make a homework assignment whether or not you brought your calculator to class today. That'd be a bummer. Pop quiz, do you have your calculator? Okay, shush. If our x min is negative pi over, what did I make it? Negative pi over 4. You can literally type that in, negative pi over 4. That can be helpful for making your windows match. What would I make my x max? Pi over 2. I can literally type that in. Don't worry, the calculator knows who pi is. Pi over 2 will just make it nasty decimals. We could have our tick marks if you wanted to. You could make it pi over 8 because that's what we ended up doing in our graph. Our y min, I guess we could make negative 10. I think I've had it more like negative 5 and then maybe positive. Let's do negative 5. So I want more positive. But could you get your graphing calculator to look like ours? I did. But it wasn't easy to put in. Hey, we did a good job. What's not there? The cosine's not. Why? Because secant is not cosine, but he bounces off of them. So the dotted line is to show you there's the cosine. Secant, it doesn't even show the vertical asymptotes, but it's important to know that they're in between. Secant is literally, though, just the bounce, 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 boing, 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 going off. Well, let me show you my window one more time, because a few of you guys are like, I did not know how to put that in. 3 plus 2, you can do it a couple ways. You can do 2 over, or you can do 2 times 1 over, if that makes more sense. Secant is 1 over. But you need to put all this stuff in your cosine, but there's a parenthesis. Some of you got confused with the parenthesis. Like, wait, no, I want the 4 before the parenthesis. It doesn't matter. A parenthesis is a parenthesis. Put the 4 and then another parenthesis. That's okay. Or multiply the 4 in and then just write that inside the cosine. But either way, I'm in radians. I have my window. How many of you guys got to this graph before I did? Ah, see, it wasn't so easy. Good job, those of you that did get there. Those of you that didn't, do you have any questions or does it make sense? None.
When you were plugging into the window, like the X min
Yeah.
X max. Could you say how you did it again?
Oh, I literally just looked at our picture because I wanted to go ahead and be able to compare. And so the closer the left and right and down and up is, the better it'll like match what's here. So I went ahead and saw that negative pi over 8, we had gone one more tick mark, so I used negative pi over 4. So literally, Melanie, I was just typing in negative with a pi.
Yeah.
And then divided by 4. So you can do that, and then when you hit enter, a nasty decimal appears, but whatever, I have my quantity. So that was my x min. My x max, remember, is how far right, which is pi over 2. My y min, I didn't really put tick marks, but I decided, like, okay, well, if this is 5, I want to go up to maybe, like, 10. Maybe I just go down, like, negative 5. So I kind of just guessed on that one. You could have gone negative 2, or you could have even gone negative 10. I just needed to make sure that I had the 1 to 5 and extra. So I just went negative 5 to 10 to have it be somewhat close. And I was able to see not only the 1 to 5 inside, but I was able to see some extra on either end. Does that make sense, kind of?
Yeah.
Cool. Any other questions about the calculator? If you're in degrees, guys, what if I change this to degrees real quick, just to make a point? If I was to go to the mode. Are the radians going to mean anything in degrees? Well, it's going to mean something, but it's not going to mean what you want it to mean. If you guys were to go to Zoom, ooh, you know there's a Zoom trig? Zoom trig would say, wait, if you're in degrees, you shouldn't be measuring things by radians. You should be measuring things in, well, let's check out the window in just a second. Hold on. Okay, I see like the bottom boings. Where are the top boings? Where are the top bouncing offs? Yeah, I don't think my window's very high, right? Zoom trig doesn't necessarily know everything, meaning they're not going high enough to even see the other portion of the graph. So Zoom trig is good. Now I can see the top and the bottom, but do you guys notice how the window changed? It's not negative pi over 4, which is like a decimal. I mean, it is a decimal, but what's that number?
Huge.
Because degrees don't go by 2 pi's. What do they go by? 360. So it's everything's going to be bigger. They have the tick marks going by 90s, so it's all different. That's why I had you guys go in radians. All right, workspace. Good job, kiddos. Hopefully that made a lot of sense. Yesterday we were talking about finishing off 4.6, which was tangents, cotangents, and then cosecants and secants bouncing off the normal sine and cosine. So the nice thing is, by doing 4.6 at the very, very end, didn't we have to review all of 4.5 anyway? And that's what you guys did in your workspace today in your group. So good job on that. We have one more quick little topic in section 4.6. It's going to take us like 2 minutes, and we're going to go into 4.7. If you have your graph and calculators. Although we've actually kind of already looked at this. We looked at this, I think, at the beginning of chapter 4. Or no, the beginning of section 4.5. We're just going to write about it. Remember when I was introducing this idea, I was like, oh, hey, if we just graph sine and cosine, the wave goes on forever, and that's not real life. Real life is the wave varies, and more specifically, almost always, the wave isn't getting louder. Or I should say higher, sorry, I was thinking sound waves. The wave isn't getting bigger, which would be louder with sound waves. Usually it's like tapering off, especially when you're talking about like a pebble and pond. But I was asking you guys if you could figure out how to make a sinusoid not just go forever with the exact same heights. And the only way to do it is to multiply the trig by something else. The only way to dampen it, not like dampening a rag, like getting it wet, but dampening the sound. The only way to damp it or to dampen it is to multiply it by a totally other function. I mean, I guess you could multiply one trig by another trig, but it's not always as exciting as you would think. But if you multiply a trig function by a line, it might be hard to see this one. Let me write this one out so you don't have to worry about the light blue. This graph is x times sine of x, where you do have a sine curve where it starts in the middle. And it goes up, and it goes down, and it goes up. It is a sine curve. But its heights are dependent on y equals x. So the x actually is what the sine conforms to. But the sine doesn't only conform to x. Who else does the sine conform to? negative x as well. And the reason is because sign bounces back and forth between positive and negative. That's one way of thinking about it as to why it makes sense. Sign goes back and forth between a positive and a negative depending on the quadrant that it's in, and so when it multiplies by x, signs, positives, and negatives will flip back and forth between x's, positives, and negatives. So long story short, sign is going to, for one portion of it, whenever sign is positive, it's going to conform to the positive x, and whenever sign is negative, it's going to conform to the negative x. But that's going to change the height of sign. And I think we even, eventually, I think I gave this one to you. The e to the negative sign of 3x. You guys could go to your graphing calculators if you want. You could also think about sign, who he is. He does start at the center. This hasn't been shifted. There's no like addition or subtraction. It hasn't even been stretched as far as the normal sign itself. The 3x, what's that going to change though? This 3. The period. So instead of repeating, or I should say, repeating every 2 pi, what's the period going to be now if it's 3x?
2 pi over
3. So every 2 pi over 3 is going to have another cycle. But what is it skimming this time? What's e to the x look like, Lucas? What is that? Exponential growth, there's swoop up. Okay, so what's going to happen if there's a negative in the exponential?
Scoop down.
Good, it's going to be swooping down instead. So this is going to horizontally flip, right? So e to the negative x. And instead, coming down like this, right? So I could go ahead and have this e to the negative x swooping down. Can you tell technically what transformation we ended up doing in this one in order to get both boundaries? Because sign goes between positive and negative. What transformation did we technically do to get the negative x? You could say a couple different ones, but only one is the technical right answer.
So that's where it comes to y?
No. Good guess though, because technically it is a reflection across the y-axis, right? But since sign goes between a positive and a negative, this x gets multiplied by a positive and by a negative. If it's multiplied by a negative, technically, it's a horizontal flip. And why that's important is because if I was to go do a vertical flip with this one, it's not going to help. I don't want to, if I was to go do across the y-axis or a horizontal flip, it's not going to help. What I need is, across the x-axis, a vertical flip. Because if sign is in between a positive and a negative, if sign bounces back and forth between positive values, negative values, positive values, negative values, it's going to be flipping this guy's sign too, but on the outside, not the inside. Then I could go ahead and say, oh, every 2 pi over 3, the sign is going to continue. If you guys were to graph on your graphing calculator, although I should have had this come in a little bit more, it should be getting smaller. How can we make a sine curve or a wave taper off? That's the way. Multiplying by e to the negative x. And slowly but surely it's just going to go ahead and become negative. There we go. Pebble in the pond, we come back to it. Alright, this page, guys, it's not really something necessarily to memorize. It's more of an understanding whenever you multiply a trig by a function. It's going to be dampened by both the normal function itself, but also the vertical reflection of that function. That's the end of section 4.6. Let's go to 4.7. Uh-oh. Okay, as you guys get ready for section 4.7, we're starting it today. What's the calendar say? Finishing it today? I didn't even write the homework up yet, so I'm not sure. How many people is anybody going for August camp? That's one at the farm. You guys know how to access the video. To that end, Go ahead and start taking notes. Let me peek at the calendar just so I know how to revise. Huh? Honors Ken, they have their field trip tomorrow going to the farm.
You guys would be gone late.
It depends on traffic, doesn't it?
I mean, last year we got back late. Yeah, we got back last year.
Your notes disappeared. Inverse trig. What's a button, actually 3 buttons, on your calculator that we have not used? 3 features, 3 functions. On your calculator that we have not used yet that has trig somehow involved in them. So question, if you were in your calculator to be in, what's an easy mode, degree mode? Okay. If you were to do sine of 30 degrees, type it in real fast, sine of 30 degrees. Equals 0.5, yeah?
Yeah.
Cool. What does the second sine button do? Use what we just did to figure out what the second sine button does. Second sine of, use one of the 2 numbers, either the one that we put in or the one that we got to plug into sine inverse. And if that one doesn't look special, try the other one. What does second sine do? Of course, I just closed my calculator. Don't know why. I can go ahead and write it here. And how do you guys put in sine of 30? And I'm telling you to plug in one of those numbers to sine inverse. Did anybody try plugging in sine inverse of 30?
Yeah.
What does it equal? Good. Couldn't possibly be anything. So if you're not taking sine inverse of 30, what are you maybe taking it of? The other one. What happened, people that took it of 1 half? Ooh. It's a question. Does sine with this little -1, does it flip it? Nope. So it's not cosecant? Question. In your calculator, what's 1 over cosine? No, sorry, what's 1 over sine? Yeah, so plug it in. What's 1 over sine of 30? 2. Is this -1 a reciprocal? But why am I talking about this? Whenever you see a -1, what do you normally think of doing? X to the -1 is 1 over x. Totally true. X to the -1 is 1 over x. X to the -1 is the reciprocal of x. Sine to the -1 is not. Ooh, so what's the other use that we've seen of -1 this year? And what does inverse do? It doesn't do, it undoes, right? It doesn't do, it undo. That's weird. It undoes. Sine of 30 gets to 1 half. Sine inverse says, give me the 1 half and I'll give you 30. Hey, the x's and y's? Switch. That's inverse. That's inverse. So question, what if I was to give you something like sine inverse of 0.9? Ooh, that's a little bit below 1. What's sine inverse of 0.9? Okay. How about sine inverse of 0.999? Do 3. 87. Weird. How about sine inverse of 0.9999? Do 5. What's it approaching? Why is it approaching 90? What's sine at 90? What does sine equal at 90? What is sine of? 1. Okay, so then what's sine inverse of 1.1? Oh, it should be right above 90, right? What? Oh. What's sine inverse of 1.2? What's sine inverse of 5? What's sine inverse of 10? What's sine inverse of 100? Why can sine inverse not ever be taken of any number over 1? How high does sine go?
1.
And then what's it start doing? And then how low does it go?
-1.
So someone tell me a negative number that wouldn't work in sine inverse either. Negative 1.1, negative 2, negative 3, negative 10, negative 100. Sine inverse says, give me the in-between fractions between 1 and -1, and I'll give you the angles it goes with. Does that make sense? I don't know why I'm playing this table. Okay, so then coming back. Before we can take normal sine and find his inverse as a function, we've just been playing with like the calculator function. Before we can get like the equation for inverse, we actually have to start by thinking about sine himself. So kiddos, get me a quick little sine curve, a normal one. Graph y equals sine of x. The graph in between negative 2 pi to 2 pi. So I should have two different cycles. Let's review sine real fast. How would you graph sine? 2 cycles between negative 2 pi and 2 pi. Normal sine. Yeah, so if you're going up 1 and down 1. Marking quarter seconds. You can start in the center. Technically, since I cut the bounds, I would stop there. If we're talking about inverse, why is it a struggle that this one fails the horizontal line test? Does anybody remember why it's been? Why is it a struggle that he fails the horizontal line test? Sine will always and cosine will always fail. Yeah, why is that bad? Good. If an original function fails the horizontal line test, what's going to happen when I know this one's really tricky to think about reflecting. What's going to happen when we reflect the sine curve across y equals x? It's going to fail the vertical line test. It's going to fail it pretty stinking bad. Because it's going to fail all along its curve. And here's the struggle. Any function that fails to have an inverse that's a function, the calculator cannot possibly solve for you. Wait, what? But we just put, the calculator can't solve for you any function whose inverse, or I should say any inverse that is not a function. Here's the reason why. The calculator, you ask it a question, and what's it give to you? How many answers? You type in a question, 2 plus 2, and it pops out what?
4.
You type in square root of 25, it pops out. You type in sine inverse of 1/2, and it pops out. But the problem with this one is, though, the calculator gives you one answer, but technically, how many answers are there for when sine is 1/2?
4.
Not even just 4. In 0 to 2 pi, there's 2. Quadrant 1, pi over 6, and quadrant 2, 5 pi over 6. What happens if you rotate one full revolution and come around again? So this is now 13 pi over 6, and this is now 17 pi over 6. What if you go 2 full spins, and now how many different times can you land on an angle? Infinite. There are infinite answers to this, so how is your calculator only giving you one? Oh, sorry, I went to radians. Anyway, 30 or 150, and then it could be 360 plus 30, 390, and then anyway, keep going. There are infinitely many answers. How did the calculator only give you one? Because the inverse function has been cut down. The inverse function has been restricted to only include the part on the inverse that would pass the function test. But to do that, we have to steal the part on the original that would only pass the horizontal line test. So long story short, on the original sine, we have to cut the domain to be between negative pi over 2 and pi over 2. So whenever you ask your calculator to solve for sine inverse of any number, it will only give you between negative 90 and 90, if you're in degrees, or between negative pi over 2 and pi over 2 in radians. It will only give you answers here, because if it had an expanded parameter, if the programming said, go find all of them, there would be infinitely many. A calculator only gives you one. So just think, the programming is saying, only find the principal one, only give a starting one. So there's been defined an inverse trig function that says, okay, don't take the whole sine curve flipped, only take a part of it. So inverse sine as a function, y equals sine inverse of x, even though we can use it to find all the other ones using our unit circle knowledge. If we use the function itself, technically only one answer comes out on your calculator because it's been restricted, it's been cut down. And those restrictions are, well, if the domain is negative pi over 2 to pi over 2 of the original, that's going to be the range of the inverse. The y's are going to go between negative pi over 2 and pi over 2. And the x's up here in the original. Sorry, the x's of the inverse will come from the range of the original, and the range is, well, you're only going to 1 from negative 1. And this is an introduction to inverse trig. You got to think the unit circle backwards. Ooh. You got to know not only that sine of 30 is 1/2 or sine of pi over 6 is 1/2, but when asked the question, when is sine 1/2, you have to be able to come back to 30 or pi over 6. So we're going to work on that a whole lot more tomorrow. Whoa, we still have like a whole, you guys are packing up because people are yelling in the hallway. I still have 2 minutes. Party hoopers? Okay.
I wasn't packing up, I was leaning. I was leaning on my book and
So pause! Alright, if you guys don't want to write anymore and you already packed up, let's see if we can at least answer and you can come in tomorrow and take notes. So when you see arc sine, pause. That's a synonym. It's another snazzy way of typing without needing a superscript. Sine inverse, same thing. If you see negative 1/2 and you're looking for angles between negative pi over 2 and pi over 2, when will sine equal negative 1/2?
30 degrees.
It's going to be negative 30 degrees or in 30, that's negative pi over 6. You can't go the other way because the answer has to be between negative 90 and 90. So we have to go negative, but negative pi over 6. What if I'm looking for when sine is root 3 over 2? It's either 90 or negative 90. It has to be first quadrant because it has to be positive. What angle? Not 30. 60, which is pi over 3. What if I'm asking for when sine is 2? Never. Why? Does sine ever go up to 2?
No.
Can sine ever go out to 2? The unit circle only goes out 1? No. But would you be able to find this one in your head? You use your calculator then. There you go. So, kiddos, is the unit circle still going to be important? Yes. To that end, wait a minute, it's nutrition. Wait a minute, today was supposed to be if anybody did not have a unit circle quiz, their makeup. Oh. I have a unit circle quiz ready on the whiteboard right up above. If you guys want to stay in during nutrition and take it quick. 5 questions as a bonus. You did well, get out of here.
I'll take a 95.
You want to take 2 on the unit circle quiz?
You still have to finish your Bible.
I have it ready. All you need is a half sheet of paper. David, Melanie, you gonna take the unit circle thing, or you guys good? You're just talking.
Yeah.
So anybody who's taking it?
Yeah, Victor has all aces.
Like how, like basically.
You want to take that? You can make a quick answer if you want. Can I give you a piece of paper?
Justinian law code and
For evidence?
Just need mom.
the Mongol exam system for I just don't know how to explain the effect.
Wait.